Oh, I see. So we're doing problem number 24 from chapter 2, and we only need to look at parts A and C. And I've written out some information from page 57 here that we can work from to work through the problem. So it tells us when we're trying to do interpolation, we need to do 4 steps. 1, find the interval width of both scales. So for example, a percent scale versus the interval scale. And then locate the fraction of the position of the intermediate value. So for example, in part A, we're trying to find the fractional position where the number 30 lies in terms of percent. And then compare that with a number that might lie over there. So we use that fraction to find the other position, and then use the distance from the bottom or the top to determine where exactly that other position is. So let's start with the first step, okay? Interval width. Okay, so let's say the first width is going to be 45 minus 25, okay? Equals 20, okay? And then the second width is a little bit tricky. We have to think about what is the top of the interval below and the bottom of the interval above. And we know that the way real limits work is they're halfway between the top of one interval and the next. So we know that the bottom of this interval is at 69.5, and the top of this interval must be at 79.5. Okay? So now in order to find the width of that interval, we have to subtract the top of that interval from the bottom of that interval. So that gives us 79.5 minus 69.5. And that equals 10. Okay? So we've checked off part 1. Okay? We found the interval width of both scales. Now we need to locate the fractional position of the intermediate value. Okay, so second step, fraction. So in order to get from 25 to 30, for example, we go 5 units. Okay, so the first one is 5 out of 20. So we move 5 for every 20. And then we use that fraction to find the other position. So in order to find the other position, we could set up a little algebra problem. How much do I have to go in the other scale to achieve the same fraction of that interval width, which is 10? Okay? And so what you see is that you have a simple algebra problem set up. So you can easily cross multiply to set up an equation to solve. So that would look like this. 20x equals 5 times 10. Looking good? So we're basically moving straight on to step 3 here. We're using that fraction to find the other position, okay? And so in this case, if we solve for x, we get x equals 5 times 10 over 20, which equals 50 over 20, right? Which equals 5 over 2. Okay, and now 5 over 2 is equals to, 2 goes into 5 twice, 2.5. So we're not quite done yet. The last step is to use the distance from the top or the bottom, depending on where we started from, to determine the other. So I started from the bottom, right? I want to know the distance 30 was from 25. And so now we know that our number that corresponds is 2.5 above the bottom of this interval. Okay, so step 4 is simply to add 69.5 at the bottom of that interval, plus this distance value that we found, 2.5. And you'll find that 69.5 plus 0.5, that would be 70. And so this answer would be 72. Okay? 72 is the 30th percentile. So 72 is your answer for part A. So let's try to summarize that process as we do part C. Okay? Let's try to have some words that define each step. First step, we're going to call that width. Then the second step, we'll call that fraction. The third step, let's call that distance. And then finally, we're going to get the actual position. So width, fraction, distance, position. We'll call these the 4 steps. It's an easy way to remember it. Okay? So, again, we need to find the interval width of both. What is the percentile rank for 77? Okay? So now we know that 77 falls within this range here. And the real limits of that we know are 69.5 and 79.5. Okay? So the two widths are 79.5 minus 69.5. That's width 1. That equals 10. And then we might as well call that widths. And now in order to find the second interval width, we need to know that the top of this interval falls at the 25th percentile. And so that means that that's the bottom of this interval, and the top of this interval is this percentile. Okay, so we're looking between the values of 25 and 45 again. So basically 45 minus 25, can we have an interval width of 20 for that one and 10 for that one. Okay, now we need to find the fraction. Okay, so we're just working on the other end this time. So the fraction equals the actual number, here in this case it's 77. So 77 minus the bottom of the interval. Oops. 69.5. And then the fraction is over the total 10. Okay, and then we'll figure this out real quick. So that equals what? 7.5. 7.5 over 10. And of course this corresponds somehow to this other interval, which has a width of 20, and we want to know how far we have to go. So again, we just have to cross multiply 20 times 7.5 equals 10 times x. Okay, so x equals 20 times 7.5 over 10. So that's basically the same as 2 times 7.5 over 1, which that means x equals 15 over 1. Okay, and again, we're not done yet. We need to add whatever value we gotten to the bottom of the interval in question. Okay, so the bottom of that interval is 25. Okay, plus the distance that we found, 15. And we find that the percentile rank for x equals 77 equals 25 plus 15 equals 40. So the percentile rank for x equals 77 is 40%.